The universe comprises countless galaxies, each one containing numerous stars. Around some of those stars, there are planets, just like those that orbit our own star, the Sun. The nebular hypothesis is the most widely accepted explanation for how the Sun and planets in the solar system may have formed. When our solar system was first created, all that was thought to have existed was a cold, spinning cloud of gas called the solar nebula. The nebula resulted from an uneven distribution of gases throughout the universe. As the gravitational pull began to condense the gas toward the center, the speed of the rotation increased. This caused the cloud to flatten, creating an accretion disk. Matter continued to collect as the growing force of gravity drew it toward the center. Eventually, the gas warmed from the increasing pressure. As the mass further increased, the gravity also increased, and as a result, the temperature continued to rise. A ball of hot gas formed in the center of the accretion disk, creating a protostar, also known as the Sun. Finally, when enough gas gathered in the center of the protostar, the pressure generated enough heat to fuse the atoms, forming a star. Outside the star, matter was forming into clumps of gas, dust, and rock, which created protoplanets. These protoplanets continued to grow as they trapped material in their gravitational fields. Because the protoplanets all formed from the same cloud of gas and dust, they travel around the Sun in the same direction and in the same plane. The nebular hypothesis also explains how the planets are arranged. The heat and solar winds caused by the Sun swept the lighter gases farther out into the developing solar system. This is why the rocky terrestrial planets, Mercury, Venus, Earth, and Mars, are located closer to the Sun. The gas giants, Jupiter, Saturn, Uranus, and Neptune, formed in the cooler outer region of the solar system. The solar system continued to evolve even after its initial formation. Large asteroids slammed into planets, and the planets themselves differentiated into layers as they slowly cooled. Although the nebular hypothesis cannot be directly tested, it is a useful description for how a solar system forms. It explains why planets and the star they orbit usually spin in the same direction and lie in the same plane. It also explains the arrangement of the planets, with the rocky planets nearest to the Sun and the gas giants farther away. The next time that you look at the stars twinkling in the night sky, imagine new planets forming using these very steps.